Hi, I'm Rob, N1NUG, and I've somehow broken the HM-31 microphone that goes to my Yaesu HM-31 ham radio. Well, this microphone's okay. The one that's all taken apart on the desk is the broken one. I went out to do a POTA activation last weekend and found the microphone wasn't working, so I wasn't able to do the POTA activation. When I got home, I did some basic troubleshooting and determined that the cable and all the wiring of the mic was fine. It was the dynamic element inside that had failed. Now I could very easily go online and order a new one. These HM-31s are readily available from the major ham radio retailers. They're even available on Amazon and eBay. But you know me, I'm a cheapskate, and I've got a lot of parts laying around. So I thought I should be able to fix this thing without spending a ton of money. Here is what an HM-31 looks like when you take it apart. We'll take the good one and set it aside. We of course have the back half of the mic. I've got all the screws just laying in there. There are 2 screws on the bottom and 1 that goes through the mic holder. And then there's a few screws that hold this circuit board assembly into the front half. And you can also see on the front half there is just a metal plate here to give it some weight and the push-to-talk switch. One of the nice things about the HM-31 is that it has a modular mic cord, so you can easily unplug this and plug in another one to either check and make sure that it's good or replace it if it's failed. And I've checked this one out and it's good. There's no problem with it. And then here's the mic assembly itself. There's really not a lot to it. There's 3 buttons up on the top and then one over here. This is the push-to-talk switch. We of course have the dynamic cartridge itself right here. And then if I flip it over, you can see there's a switch here. This is the tone switch. And then on the bottom is a modular jack for the cord. And then of course just the circuit board that holds everything together. To test out the mic element, I've got my multimeter set to the resistance scale. And I'm just going to probe the 2 terminals that are on the side of the cartridge by checking the ends of the wires here on the circuit board. And if I probe across the 2 wires, you can see on the meter we're getting open circuit. Now because this is a dynamic element, if it were functioning properly, we should get a resistance reading across the terminals. But because we're not getting any reading on the meter, I think this has failed open. In other words, the coil that is in here has broken. And I'm willing to bet that that was caused by me dropping this microphone one too many times while out on a POTA activation. I've got a box full of old microphones and microphone parts. And of all the microphones that I'd consider parts microphones, none of them had a dynamic element that was quite this size or shape and wasn't going to work inside this particular microphone body. I looked through all my parts drawers and ended up finding an electret condenser cartridge that I think we can make work in this microphone. But as you can imagine, the electret condenser microphone is going to require a little bit different circuitry and some mechanical modifications to get it to kind of fit and stay inside the microphone. Now luckily somebody's already kind of been through this before me and documented their experience on the internet. So let's head over to the computer and check out his notes before we get started. So here's what I found on the internet. This is a little project put together by M0UKD, and I'll of course leave a link to this site below in case you want to look at this in some detail. But you can see that he's put together a schematic showing us how to wire up this electret condenser cartridge. It looks like what we're going to need is an 8.2K pull-up resistor or biasing resistor to help power the condenser element. And then we're going to need a 1 nanofarad, what I'll call a bypass capacitor to help prevent RF getting into the cartridge, but we'll talk more about that later in the video. And then what he's done is he has put a 1 microfarad cap and a 47 nanofarad cap kind of in parallel but switched to the microphone output, and that's using the switch that's on the back of the microphone that's already there. Now I'll let you read the article here, but the basic concept here is that when the 1 microfarad capacitor is switched in, lower frequency audio tones will be passed to the radio, which should make the audio quality a little bit better on modes like FM and maybe AM. Whereas if you switch in the 47 nanofarad capacitor, it'll help block some of those lower frequencies and maybe help with sort of those long distance, weak signal type contacts on sideband. And then if we scroll down a little bit, you can see a photo of what M0UKD has put together. His electret condenser element is here glued into the microphone body. and then you can see his wiring is here on the circuit board. Now I'm going to do mine a little bit different, but I'll give you a little bit of a spoiler alert now. I'm recording this well after I've completed my modifications to my microphone and tested it and found some issues. So I may need to go back and make mine look a little bit more like what's done here. But we'll talk more about that later in the video. So we saw from the notes online that we're going to need 5 volts at this pin on the microphone in order to power the condenser element. So because the author of the text used a different radio, I've hooked up this microphone to my FT891 temporarily so that we can probe this and make sure that the FT891 is providing the 5 volts that we need. Because if it isn't, we've got to figure something else out. And luckily, it looks like we've got that 5 volts we're going to need, so we can move forward with the project. A couple of years ago, one of the hams in my club was gracious enough to donate to me all of his old parts boxes. I guess he was downsizing and just didn't want this stuff anymore. You can see that he had these kits of parts that were all labeled and organized neatly. These are from Radio Shack, these and these are from DigiKey. So I've got everything I need for this project. Having all this stuff on hand makes projects like this easy, since there's no stores that sell this type of stuff anymore, and we don't have to go online and try and figure out where to order this stuff or wait for it to come in. I'm not really sure how old all these components are, so I think it's a good idea to check them and just make sure they're at least close to the right values before we throw them in the circuit. I'm going to start building up this circuit with the electret condenser element. I'm going to first solder on this piece of audio coax that I'll use to help try and cut down on any interference or RF that might get into this circuit. Now if we take a look at the condenser element itself, what I'll call the positive terminal is this one, and the negative terminal is this one that you can see over here is connected to the case of the electret cartridge. So I'm going to bring in the audio wire and I'm going to solder the center conductor to the positive terminal, and I'll solder the shield to the negative terminal. And while I'm here, I'll also solder on this 1 nanofarad filter cap across the terminals. There's a little bit of old solder on these terminals, so I'm going to start by adding a little new solder just to make things a little easier. Okay, now we'll bring in the wire and get this soldered on. Now we'll try and get this capacitor tacked in. So I'll just put a little isopropyl on here to clean everything up. We're not going to win any IPC soldering awards, but it should be functional. Now, I'm not making excuses, but it has been several months since I've soldered anything. And in that time, I've noticed my eyesight has really degraded. I had to put extra magnification on, and even then I was still having trouble focusing on this. But I think we've got it. Let's move on. The next thing I'll do is bring in the microphone assembly and unsolder the wires for the old broken dynamic cartridge. I don't think I pointed it out before when I was showing you the assembly, but there is a capacitor and a resistor in this circuit board that I don't think we're going to need for this modification. So the next thing I'll do is desolder these and remove them from the board. I'm also going to remove this wire on the end of the switch that connects to the circuit board. We're not going to need it, and in fact, we're going to need that hole that's in the circuit board for the next step. Now I'm going to use a little solder wick to clean up these solder pads. I'm just going to check and make sure that I can pass a lead through these holes, and then I'll know that I've got them cleaned up good enough for the next step. Now that I've got all the old components out of the way, I've started to bring in my new components. Here's my 0.05 cap and my 1 microfarad cap. And you can see I've got one lead on the terminal of the switch for each capacitor, and then the other lead goes into the circuit board to complete the circuit. You can see that the trace for the audio lead of the microphone comes down to the switch to this terminal here, and then goes through the switch, and then comes out one of the 2 terminals depending on where the switch is positioned. So we've got one leg of each component on that terminal on the switch, and then the other leg is connected directly to the audio line that goes into the radio. So if the switch is in this position, the 1 mic cap will be in the circuit, and if we move it over, then the 0.05 cap will be in the circuit. So I've applied just a little bit of no clean flux to these solder joints just to help this solder flow. paste will be especially helpful on the switch terminals. Now I can just trim off the excess leads. Now I may need to change this out later depending on how everything works, but for right now, I'm going to stick with the 8.2K resistor that M0UKD used in his circuit. Although I'm going to attach it to mine a little bit differently than what he did. You can see that I've got this lead kind of bent around and touching the pin on the connector that gives us 5 volts. I'll drop just a little bit of paste in here. Let's see if I can do this without shorting anything, even though I can't see. Again, I'm not going to win any IPC awards for my soldering, but I think it's functional. Trim back this excess lead and get it out of the way. And I've just realized that that lead ended up soldering itself to the other pin, so we'll have to get that out of the way. Here's another example of why we call this amateur radio. You guys probably saw this happening in real time, but I didn't see it until just now when I inspected everything. But the way I routed the lead of the resistor, once I heated it up, it melted itself to the locking pin on the connector body. Now, if I end up having to change this resistor, it may screw up this locking pin, and then I may need to find a new way to glue this down to the board. But I think for now, I'm just going to leave it like that. It doesn't seem to be hurting anything. So I've slipped a bit of heat shrink tubing over the resistor. Once this lead is soldered down to this point here, hopefully this doesn't shrink too much from the heat. And I can slide it over the lead and insulate the lead from these 2 solder points that are right below it. Get a little paste on here. Actually, that's probably too much. And now I'll try and solder this as quickly as I can with the least amount of heat. I was able to slide the tubing over that joint. Now we should be able to just shrink it down. And I want to be careful I don't put too much heat on here so I don't end up melting these solder joints. And then we'll just trim off this lead and we should be good to go. To attach the electret element to the mic body, I could fill this up with hot glue, kind of the way M0UKD did, and I think it would probably be fine. But I think what I'm going to do is try and glue in this washer, and then bring the element and center it in the washer, and then glue it to that. I don't know if my method's going to be any better or worse than what was done online. I'm just going to do it so I don't have to fill up the inside of the mic with glue. So I ended up with a little more glue in here than I originally anticipated, but that washer isn't going to go anywhere. So I've dropped in the electret element in the center of the washer, and now I can just add some glue between the edge of the element and the washer body. Once again, I've probably got a little more glue in there than I really need, but let's let that cure and then move on. Now that everything is glued in place, I can solder the audio wire to the circuit board. Again, I'm going to drop just a little bit of flux here, just to make the soldering a little easier. Now, even though I used no clean flux, I'm going to just kind of clean everything here with some isopropyl alcohol before I do the final reassembly of the mic shell. Now I'll get the screws installed that hold the circuit board down. I had a feeling that this was going together a little bit too easily. You can see here that the clamshell doesn't quite fit because I'm getting interference from this resistor that I put here. I'm going to have to squeeze on this to really get it to close up. So what I might end up doing is cutting the heat shrink tubing off of it. With that removed, we might have enough clearance for this to close. But I'm not going to do that just yet because we might need to change that resistor for a different value. So I'm just going to leave it like this for now and test it out and see what it's like. And then we'll decide what to do with the resistor after. One thing you may have just noticed is that I've switched the mic holder on this with a silver one from one of my junk microphones. And the reason for that is since I have 2 of these microphones, I'll be able to tell them apart. I'll know that the silver one has the condenser in it and the other one is the standard dynamic element. Now that the microphone is all put back together, let's try it out and see what it sounds like over the air. I'm going to set up the 891 so that it will transmit into a dummy load. On the other side of the room, I'll set up my SDR Play RSP receiver and hook it up to the computer so that we can listen to the transmit audio and see what it sounds like. Now I'm going to test the condenser mic with both switch settings, and then we'll switch over to the dynamic mic and check this one too. And we'll do the test on AM, sideband, and FM. After the test is over, Let me know in the comments what you thought sounded best and sounded worst. And I'll do the same here on the video when we come back from the test. One last thing before I start the test. I've set the mic gain on this radio to 33 for each of the 3 modes we're going to test, AM, FM, and sideband. Now in sideband, I've also done a test with compression on and compression off, and when it's on, I have it set to the level of 23. I haven't touched any of the other settings relating to transmit audio, including the EQ settings that are buried in the menus. Testing the condenser mic in AM mode with the switch set to 1. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the condenser mic with the switch set to 2 in AM mode. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the dynamic mic in AM mode with the switch set to 1. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the dynamic mic in AM mode with the switch set to 2. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the condenser mic in FM mode. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Switch is at position 1. Testing the condenser mic in FM mode with the switch at position 2. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the dynamic mic in FM mode with the switch at 1. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the dynamic mic in FM mode with the switch set to 2. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the condenser mic in sideband with the switch set to 1. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the condenser mic in sideband with the switch set to 2. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the dynamic mic with the switch in position 1 on sideband. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the dynamic mic on sideband with the switch at position 2. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the condenser mic on sideband with the switch at position 1 and the processor on. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the condenser mic with the switch at position 2 in sideband and processor on. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the dynamic mic on sideband with the switch at position 1 and the processor on. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Testing the dynamic mic in sideband with the switch at position 2 and the processor on. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Now that I've had a chance to listen to all those audio clips, it's pretty clear that the condenser mic does have more punch. But that's kind of what I expected after looking at M0UKD's notes. But having said that, I think the dynamic mic does sound a little bit more natural. Now keep in mind, I didn't play with any of the available EQ settings or anything like that. The only thing I changed was to set the mic gain at 33 and the compression went on sideband to 23. Playing around with the EQ settings and the mic gain to have the optimum setting for the dynamic mic versus the condenser mic would probably equalize the sound of these two microphones. But having said that, my goal for this project was never about transmit audio quality. It was really just to fix a broken microphone with parts I had laying around the shop. And to that end, I'd say we've been quite successful. So I ended up taking the Yaesu and the newly repaired microphone out on a POTA activation in what I'll call less than ideal conditions. I had the radio sitting on the seat of my car with a tuner in line and a ham stick on my fender, so what I'll call kind of a high RF environment. Well, I was able to successfully activate the POTA park I was at, but I got a couple of reports telling me that I was getting RF into my transmitted audio. So it looks like we've got a little bit of an issue to contend with. Now, I've got a couple of theories as to what might be causing the problem. It may be a combination of those or something completely different. If you've got any ideas, let me know in the comments. I'd be curious to hear what you think. But here's what my current thoughts are. First, we might need a little more filtering capacitance in there to help get the stray RF to ground. That 5-volt line that's on this microphone could just be what I'll call dirty, and we need more filtering on it. Another possibility is we might need to put an RF choke in line somewhere to help block the RF coming into the microphone element. I'll see if I've got one in my junk box that'll fit in here. Another possibility is that the gain is just too high. I know I used the resistor that M0UKD suggested in his schematic, but his radio was an FT817. It's a little bit different than the 891, so we might need to change the value to lower the gain a little bit. And honestly, we might have needed to do that anyway, regardless of the RF interference issue. This microphone did just seem just a little bit too hot. And then the last kind of working theory I've got is that the washer that I put in there to sort of hold the element and also to add a little bit of weight back to the microphone, since we took that big dynamic element out, could possibly be receiving a little bit of RF and coupling it directly into the condenser element. I'm not sure. So I think we've got some changes to do to this to really make it usable, at least when the radio is portable. So keep an eye on my channel for that video. When it's available, I'll link it below and up here. But having said all that, I hope you enjoyed this video and maybe it gave you some ideas to either fix your microphone or maybe you want to try a condenser just for the fun of it like M0UKD did. Either way, 7-3 for now, and thanks for watching.